Okay, so welcome back. Now, in this video we're going to talk about determining what p-values, what values of p will determine whether a p-series converges or not. Okay, so we're going to consider different values or different intervals of values for p. So let's consider for negative p-values, values of p. So if p is negative, well, what happens? We get 1 over n to the p, but what happens to 1 over n to the p? If this is negative, p is negative, well, what happens as n goes to infinity, right? Okay, so if we look at this, what happens to 1 over n to the p, right? So again, let's look at the nth term. Well, actually, let's do this. Let me write. Okay, so let's consider p less than 0. So that means 1 over n to the p approaches what? Infinity. As n approaches infinity. Okay? Now what about if p is equal to 0? Well, if p is equal to 0, then 1 over n to the p equals 1. And in both of those cases, by the divergence test, the p-series diverges. Okay? So by both of these, the divergence or test for divergence test or test of divergence okay, so by the divergence test, both of those cases, the p-series diverges. Okay, so now what about for p greater than 0? Well, in this case, we're going to use the integral test. Okay, because for p greater than 0, this series is has positive terms, right? So it's positive terms. So what we could do is we could use the function. We could use if you want the family of functions equal to 1 over x to the p, right? So and oh, by the way, this is a continuous decreasing function that behaves just like the series at the integer values. So if you plug in n, so for every value of f of n equals a sub n. So again, so it meets the conditions for the integral test. So now let's set up our integral and see what happens. So let's do the integral. So we're going to do the integral from 1 to infinity of 1 over x to the p dx, right? And now we're going to take the limit as t approaches infinity of what? The integral from 1 to t of 1 over x to the p dx. And now if we integrate this thing, we get the limit as t approaches infinity of what? Well, how do we integrate this? Well, we're going to increase the power by 1. So this will be x to the negative p, right? So what happens? We're going to take negative p plus 1 and then divide by that. So in this case here, it's going to end up being what? It's going to end up being 1 over what? One over negative p plus 1 over what? It's going to be, well, it becomes x to the p plus 1, but then when you bring it down to the bottom it becomes negative, so it's going to be x to the p minus 1 from 1 to t. So does that make sense? Okay, now let's rearrange this a little bit. Well, let's just keep it this way. Let's just see what happens, okay? So now, what happens to the limit? Well, this is going to become the limit as t approaches infinity of what? It's going to be the limit of 1 over negative p plus 1 times 1 over well, actually, just write this. Let's write this as just x to the 1 minus p. Okay, there we go. So now, at t, this is going to end up being t, right, to the 1 minus p power. Okay, and this is going to be minus everything evaluated at 1. Well, at 1, this is just going to become 1, so we get minus 1 over negative p plus 1. Well, now, here's where I'm going to change things a little bit. So I've got a negative. I would rather write this as, oh, by the way, hold on. Yeah, let me oh, you know what? If I distribute this negative, let's make this a positive, and I'm going to make this into a positive, and I'm going to make this into a minus, right? So this is just going to become p minus 1. Okay? So now what? Well, when does this thing converge? Well, let's find out what values of p will make this thing converge. But before I do that, let's do one more thing. So this here is not dependent on t. So this is the only thing dependent on t. So let's factor out everything that's not dependent on t. So this is going to be equal to 1 over p minus 1. Or wait, actually, you know what? Let's do, because this is just the same as 1 minus p. And this is just the same as minus 1 minus p. And so let's factor out a 1 over 1 minus p. And this is going to be the limit as t approaches infinity. And what's left over is going to be the limit of t to the 1 minus p minus 1. Okay, so now that's what we have. Okay, so now what happens to this thing? Okay, so here, what happens to this? Well, so we're going to be positive, so p is positive. So what values of, okay, so again, what values of p is going to make this limit go off to infinity? And what values of p is going to make this thing approach a particular value? So let's look at values that are less than 1. Okay, so if we put in p, a value of p that's less than 1, this whole thing is going to be positive, right? And if so, what happens as the limit goes to infinity? The whole thing's going to go to infinity, right? Because if p is less than 1, we get 1 minus something less than 1, so we get something positive, right? And so as t goes to infinity, this whole thing is going to infinity, okay? And so this whole thing goes to infinity, and the series diverges. Okay, good. Now what happens when p is equal to 1? Well, if it's equal to 1, then you get 0, and you get t to the 0, which is 1. You get 1 minus 1, which is 0. And so then you get 0, right? And so in that case, what happens? Well, what does the test by divergence say? We already did that one, right? Or excuse me, that was for 0. So here, you get, it goes to infinity, right? So the issue here is you get 1 over 1 minus 1. And so this is 0. So this is undefined, right? Okay, and we already considered the case when p equals 1, that's the harmonic series, right? So we know the harmonic series diverges. Okay, so now, what about less than 1? Well, or excuse me, no, we already did less than 1. Well, what about greater than 1? If we're greater than 1, then what do we have? This is going to be negative. Right, so that's not an issue. Here, what happens to this? Well, this becomes negative exponent. And so what happens to this? This becomes 1 over t to the positive exponent. And so as t goes to infinity, this is going to 0, and you're going to end up with the opposite, right? You're going to end up with negative 1 over 1 minus p, or in other words, 1 over p minus 1. So that's what we end up having. So in conclusion, here's what we end up having. After all this, here's what we know about the p-series. Okay, so for the p-series, we'll write it okay. For here, it's going to be equal to, it's going to converge, and it converges to 1 over p minus 1 for p greater than 1. And goes to infinity for p less than or equal to 1. So basically converges. Oops. And diverges. Oh, hold on. I was looking at the wrong one, sorry. I jumped ahead of myself. Okay, so in conclusion here for the function, f of x equal to 1 over x to the p, what do we have? We have, it's going to equal 1 over p minus 1 for p greater than 1, and it's going to go to infinity for p less than or equal to 1. And so by conclusion now, what we have is we know by the integral test that the series, and of course the other test we ran for divergence is going to go from 1 over n to the p. So the p series we know is going to converge when p is greater than 1, and it's going to diverge when p is less than or equal to 1. Okay, and that's the final result. Have a great day.